Hello everyone, Mr. Cruze here with another review for you. This time, Probability and Statistics, the Chapter 8 test, which should really feel more like a quiz. I believe it is 4 multiple choice, 2 true-false, and 4 of these hypothesis testing questions, alright? We're going to fully run through these hypothesis test questions. This video, I'll probably get the first 2 done, and then I'll have a second video. Link is in the description. For the other 2 problems. Alright, let's just dive right in. Basically, there's one problem from each section. You just need to figure out how to do it. Really, what's going to change in each problem is how to calculate the z-score. Okay, so that's really what is going on. A recent article in Vitality magazine reported that the mean amount of leisure time. Alright, mean amount. Already, I'm down to means. So this is either going to be a 1 mean test or 2 mean test, and we'll get to that here in a second. Per week for American men is 40 hours. You believe that this figure is too large and decide to conduct your own test. In a random sample of 60 men, you find that the mean is 37.8 hours of leisure per week, with a standard deviation of 12.2 hours. Using the 5% significance level, can you conclude that the mean amount of leisure time per week for American men is less than that claimed in Vitality magazine? You might be tempted to think this is 2 means because there's 2 means that are given, but one of them is the population mean, right? That's the one that the Vitality magazine reported. Really, I think the trick here is look for number of standard deviations. If it's 1 mean, there's only going to be 1 standard deviation given. If it's 2 mean, there's going to be 2. And here, in the whole problem, there's only 1 standard deviation. So that means it is going to be a 1 mean test. Alright? So, step 1. The null and the alternate hypothesis. Alright? Always look at this last sentence. Can you conclude that the mean amount of leisure time per week for American men is less than? This is your alternate hypothesis. So, the mean, mu, is less than what was claimed in Vitality magazine. Well, they said it was 40 hours. Okay? The part that was claimed in Vitality magazine is 40 hours. If the alternate hypothesis is mu is less than 40, the null hypothesis is the opposite of that, or greater than or equal to 40. Remember, the null hypothesis always contains the equal to part, whether it's strictly equals, less than or equal to, or greater than or equal to. That's step 1. Step 2 is identify the level of significance, which in this case is 5%, which is 0.05. Not a difficult step there. Step 3. This is obviously a z-test because our sample is 30 or more. It's 60, right? And this is a 1 mean test. And again, the only reason I write that is so that I know it's a 1 mean for when I calculate the z-score. So step 4, I need to look right here and ask myself, is this a left-tailed, right-tailed, or two-tailed? Since it's less than, that means it's left-tailed. So when I go to draw my little sketch of what's happening, I draw my bell curve, and it's going to be on the left. And that's your alpha value, 0.05. Alright, so I'm going to go to my table and I'm going to look up the z-score for 0.05 probability, and I believe it is between 2 values. It's between negative 1.64 and negative 1.65. Because it's exactly between, you're going to use z as negative 1.645. So, why are we going to reject? We're going to reject if our z value that we calculate is less than, and I say less than because we don't want it to be in this shaded region, is less than negative 1.645. Alright? That's step 4. Step 5 is to actually calculate the z-score. If it's a 1 mean test, and again, you'll have your notes for this, it's x bar minus mu over s divided by the square root of n. Okay? And remember, you can just type this directly in your calculator. X bar is your sample mean, and the sample mean is 37.8. Mu is the number used over here, which is 40, divided by s is your standard deviation, which is 12.2, and the square root of n is the number of people you sampled, which in this case was 60. Alright? When you type this all in your calculator, you should get a z-score of roughly negative 1.40. Okay, if you get that, great. If not, come see me in the morning, I'll show you how to type it in the calculator. Is negative 1.40 less than negative 1.645? No, it is not. So we are not rejecting. Do not reject the null hypothesis. We cannot conclude whatever the last sentence says. That the mean amount of leisure time per week. I'm just going to abbreviate here. Mean amount of leisure time. Leisure time per week is less than 40 hours. Again, abbreviating here, but that's fine. Alright? That's really the answer we're looking for. Once again, I'm going to show you how to do p-value, just to make sure that we understand that. Okay, p-value is an alternate way to do this. To do the p-value, you're going to look up negative 1.40 on the table. That's the z-score you came up with. You're going to look up negative 1.40 on the table. Since this is one-tailed, you don't have to do anything with it. You just have to look it up. The probability is 0.0808. That's your p-value. Well, 0.0808 is greater than, I almost said less than, it's greater than our alpha value, which is 0.05. And if p is greater than alpha, that means you do not reject, which just confirms what we said. Okay? Remember, I'm going to have you find the p-value once. I honestly prefer z-score myself, but I'm only going to have you do one p-value. Alright, so make sure you know how to do it. Number 2, suppose the manufacturer of Advil developed a new formulation for the drug that is claimed to be more effective in relieving a headache than the one currently sold. To evaluate the new drug, a sample of 200 current Advil users is asked to try it. After a 1-month trial, 180 indicated that the new drug was more effective in relieving a headache. Alright, let's pause right there. 180 out of 200. Anytime you have something that's out of or something along those lines, you have a proportion. We just need to figure out if we have one proportion or two, right? At the same time, a sample of 300 current Advil users is given the current drug, but told it's the new formulation. From this group, 261 out of 300. So, there are two proportions happening here. Two different groups. At the 5% significance level, can we conclude that the new drug is more effective than the current drug? Alright. Step 1. Null and alternate hypothesis. Again, look at the last sentence for the alternate hypothesis. Can we conclude that the new drug is more effective than the current drug? So this is a proportion, so we're going to use pi. And we want the new drug to come first. So pi new, I'm just going to use n. More is greater than, and then pi c for pi current. Again, if that one's greater than, the opposite would be less than or equal to. All right, remember the one without the inequality, or the one without the equality, is the alternate hypothesis. All right. Step 2, alpha, that's 0.05. Won't always be 0.05, but it is in this case. Step 3, this is a z-test because both of our samples are larger than 30. But this is a 2 proportion, so we'll have to remember that for when we do our formula. Step 4, since it's greater than, that makes it a right-tailed test. So I'm going to draw my little pretty sketch. Ooh, I can draw a better sketch than that. There we go. That's a little better. And I'm on the right-hand side, and I have 0.05. Again, look up the z-score. I'll give you a hint. 0.05 was on the left in the last problem, and it was negative 1.645. So if it's on the right, it's going to be positive 1.645. Again, you start to see the same numbers coming up all the time. We are going to reject if our z-value is greater than 1.645. And I say greater than because we're on the right this time. We don't want it to be in the shaded region on the right. Alright, step 5 is the z-score. I will tell you, 2 proportions, it's probably the most complicated formula we have. It involves, you have to have two different proportion, and you have to have a couple of different things. You have to have a combined probability, 2 different sample sizes, right? There's a lot going on in this one little formula, right? So we need to figure this out. Proportion 1 is the first one that we list in this part of our problem. So it deals with the new drug. So we need to go back up to the new drug. And that is 180 out of 200. It may not necessarily be the first one listed, okay? So make sure you're matching up. First goes with first. 180 out of 200, by the way, is 0.9. P2 is the other one. It's the one that comes second. That's the current drug, and that's 261 out of 300. And when you turn that into a decimal, you get 0.87. Your combined probability is simply add the two successes, if you will, from both groups over the total number of people in both groups. So it comes out to be something like 441 over 500, which is 0.88. Alright? So, we can start plugging some stuff in. I'm going to do 1 minus that. 1 minus 0.88 is 0.12. So literally, you just start plugging this stuff in. So this top part becomes 0.9 minus 0.87. And then I just start filling in the bottom here. I'm going to cheat and erase all this stuff. It was the combined probability, 0.88, times 1 minus that, over the number of people in the first group, plus the same decimals, the same combined probabilities, but this time divided by the number of people in the second group. Alright? When you do that, and you combine them, you should get a z-score of 1.01. Now, remember, we're going to reject if z is greater than 1.645. Well, 1.01 is not greater than 1.645, so we do not reject our null hypothesis. Do not reject the null hypothesis. And we cannot say, or we cannot conclude what the last sentence says. We cannot say that the new drug is more effective than the current drug. Okay, and you can imagine why a company might find this information useful. We cannot say that the new current drug. We cannot say the new drug is more effective than the current drug. And again, we're going to look up the p-value here in a second. Remember, this is your z-score. When you go to look up the p-value, you're going to look up, I'm going to write it over here, you're going to look up negative of that. Alright, negative 1.01. Even if it's positive, look up the negative. When you do the p-value is 0.1562. Since it's not two-tailed, you don't have to double it. And 0.1562 is bigger than 0.05. Which means p is bigger than alpha, which means do not reject. It just confirms what we said already. Alright? There's the first two problems for you. I'll do the next two in the next video. Check the link in the description for more. If you have any questions, please tweet me, email me, or come see me in the morning. Alright? Good luck studying.